Hello everyone, welcome to Practical GCP. I finally got around trying out the Cloud Datastore TTL feature, which was recently made GA by Google Cloud. And this is the feature that allows you to automatically expire data on Cloud Datastore. So this is something that's been really useful. I'll show you a number of use cases that you can use this for. But it has been available on DynamoDB on AWS for many years, and it's finally good to see Google kind of catching up on this TTL feature, which is one of the very important things to have as a document store. Let's first talk about what is TTL. And TTL stands for time to live. If you look at the example below, it's just like a very simplified table with, let's say, two rows, right? So you've got the two, let's say, users, like called customers. You've got dummy2 with address and two different addresses, but then you have typically a date or timestamp column in there that makes the record expire at that time or around that time. So most systems where the design time to live is usually not exactly at the time of the expired time, because this is typically designed as a kind of a low priority system to kind of have as a cleanup process for anyone who have used distributed systems on the Hadoop ecosystem, such as HBase. So there's kind of a process called compaction. So that's when the records like these gets cleaned up. So the TTL on Datastore is not that much different. So there's kind of a time period. Later on, we'll talk about these kind of details on how after the expiry date is reached, it will start kind of cleaning up those records in the background. So let's talk about the number of use cases which this can be very useful for you. The first is use the TTL to manage the sensitive data. And so you can see the date I've set these two records to today at 8 a.m. and 9 a.m. UTC, right? So basically what happens is you can use the TTL feature to automatically expire your records like these when the timestamp is reached, right? So as from that point time onwards, you'll start cleaning out data typically like in a couple of days or a couple of hours, depending on how busy the clusters are behind the scenes. The other one is about in my opinion, very useful in terms of keeping the most recent data, because if you store a huge amount of data, especially in this scenario, you've got customers and the transactions associated with those customers, these data can be quite, a lot, right? So, and then when you have to keep these, for example, in Datastore, it's typically used as a cache that maybe you serve data for the last month or last couple of months, right? So then you may not need to keep all of the data in all history in this place. So then in this scenario, I've kind of modeled in a relational manner, but it's not it's not a relational database, but you can see this is easier for you to understand, like these are linked, right? So you've got customers, there's two customers, and you've got three records that two link to customer one link to customer two, right? So, but you basically say, if you look at these three records in here, you've got the date and time of transaction number one is actually made on the 29th of September. So does the second one, but the third one is actually done on the 29th of October, right? So what I've done here is I set the expiry date, the expiry timestamp, to exactly a month away from the date. So what I'm trying to say is I just want to set the TTL to expire those records in a month's time. So within that month, so always I'm going to look at is last 30 days of records. I don't actually need them for anything like 30 days. Let's assume you have that kind of business scenario, right? Then you don't have to go and try to clean these up yourself. You just basically say expire around that time, and then when you reach those customer records, it will expire at exactly those time frames. Then you don't have to worry about cleaning those up yourself manually, which is quite a lot of work if you're actually managing those yourself. So the last one is around you can keep the data store in sync with another data source. So typically, let's say if you have like dimension data or some of the tables which the size are not huge, right? So, but if you think about trying to keep them in sync to serve the data as a cache again in Cloud Datastore, it can be a bit of a nightmare, trying to figure out, which record has gone missing from the source. You can do delta tracking, especially for large tables. It's probably better to track the delta, let's say on an hourly basis or daily basis on exactly what has been changed, and then update Datastore. If there's something's been deleted, you can delete data in Datastore. But this is a use case. Let's say you have a table with 1 million records, and as an alternative way, you can basically just say, okay, every record I put in there, if you look at the examples below, right, every record I put in there, I'll basically set a expiry date in 2 days, right? So plus 2 more days, and in 2 days time, it will expire. So if you imagine you sync, all those 1 million records every single day, if you actually haven't touched some of these records, right? Let's say the ones with, in this case, the number 3. So number 3 in this case is missing, right? So the source has deleted that data. So then when you do the sync, it will not touch anything like has number 3. So after 2 days later, number 3 would be, it would be automatically expired because you've set the sync to expire on this date. But for all of the other records, and then you'll keep refreshing your expiry date, and you will basically keep the two in sync with all of these the records that are no longer in the source automatically removed, right? So that's the third use case. So let's have a look how it works. I actually tried this out quite extensively. So and as usual, put some examples in here, which you can see. So this is the repo I will share in the video. But first of all, let's talk about what I'm trying to do here, right? So if you look at the main.py file, I've got a couple of functions created. If you look at the bottom, it's probably be easier to understand what I'm trying to do. The use case here is basically to mimic the scenario of keeping most recent data, right? So that's what I'm trying to do here. So what I've got here is I'm adding 2 customer entities in here, right? 2 customer records in the customer kind. And then I've got the children records, which are transactions. So I've got basically I'm adding 10 transactions for each customer records. So this would give me 2 customers and 10 transactions per customer, right? So this is what I'm trying to do. So you can have a look at those functions later on and how I'm actually doing this. One thing you probably want to pay attention is the pre-append of the SHA-2 hash to all of the IDs I'm doing in there. So the reason being, you don't really want to use 1, 2, 3, 4, 5 or these kind of number 1 or 2 or 3 these as IDs, because these are sequential numbers and they will create hotspots, right? So if you're interested more about how the key design works, have a look at the other video I've got about Cloud Datastore in my channel, which describes this in much more detail. So this is basically in a nutshell what it does, right? Creates 2 customers and attach 10 transactions to each one of them. And then this is where it gets interesting. So you can use so I've got the customer kind and then the transaction kind. So the data I'm trying to, for the TTL I'm trying to set is in the transaction kind, because I don't want to expire the customer apparently, right? I want to expire the transactions which are no longer recent, right? So this is the gcloud command. So the file store in Datastore mode or Datastore, whatever you prefer to call it, the TTL is no longer in beta. That's GA, but the command line tool is still in beta. But you can see here, the way you do it is you update the TTLs with a field, right? This is the field of your, in the transaction kind, basically a column or a field that must be a date time type, right? That's the only timestamp type you've got in Datastore. It does not support anything else. And then in the sense of collection group, that is basically the entity kind name. So you put transactions in there, and then you have to enable the TTL. So after you've done that, let's have a look at a real example. This is what I've done in there, right? So you basically say, give the transaction, set a TTL based on this field, right? Then now you can see it's serving. So after you run that command, it's basically doing that. So let's have a look at the data now, right? So what I've done is, you can see I've created the 2 customers. Let's look at the customer here in the customer app. This is the namespace I've used for the demo. I've got 2 customers here, as you can see, and then transactions, right? So these are the transactions. But look at what's happening here. Now I've got 18. So earlier I've got 20 in there, but now I've only got 18. So the TTL kind of started kicking in already, right? There's a number of things I'll go through later, but in a nutshell, just keep in mind that the TTL, no matter what you set the date to, if you look at the timestamp here, these are like many hours ago, right? But the data store, the process behind the scenes only just started cleaning up the data in here. So this is how it's designed to work. It's a low priority task, right? So you don't want to rely on the timestamp in here. Let's say if you expect something to immediately expire, and then for those records not to return anymore. That's not what this is designed for, right? It's designed to clean up the records behind the scenes with a low priority task. So one thing I want to show you is the GraphQL queries. That is quite useful. So one thing I've done here is, if you look at this, right? So I've got this is the syntax. You can read about the syntax more, but it'll probably take you a bit of time to figure out how this actually works. So you've got the select, all of the columns from the transaction, kind, right? But I've modeled it based on it's got a transaction ID, right? Then it's got a parent, which is the customer. So this is the entity with the parent-child relationship. Just basically, it's not like a relational databases, but it does give you a bit of a structure in place, so you can actually associate the data without duplicating too much, right? So then this basically allows you to find all the transactions belongs to a certain customer record. So in this case, you can see this is the prepended SHA-2 hash, and followed by underscore and the original value of the customer. Then you have to specify in this kind of syntax with key has ancestor syntax, right? So this is how you return this stuff, and then you can see you've returned all of the transactions belong to this ancestor customer, right? However, having said that, if you look at the any of one of these records, right? So you've got the key, apparently with the transaction ID, and then you've got the type and the amount, but also you've got the expiry timestamp, which is a date time, right? So you can see these two, are indexed, but this one isn't indexed. So when you try to retrieve the data, right? So if the records are expired, right? If the records are expired, they may not have been removed yet, right? Because it takes time. As I said, it's a low priority task that could happen in the background. When you retrieve the records, let's say you saw 18 in there, but they should all been expired, right? All of these should have expired 3-4 hours ago when I created them, with the expiry date of timestamp a few minutes later. So, but they haven't been expired yet. But neither you can actually use this to filter them. The reason the expiry timestamp is not indexed is because it's against the best practice to index a timestamp field, because this is a sequential thing and it can create hotspots, right? If you have lots of records have similar expiry timestamp set, this can create a hotspot if you try to use this as an index. So it's not, recommended as best practice to do such thing. And as an alternative, let's say if you're looking for the transactions of the last 30 days belongs to a customer, what you would probably should do is, if you look at this query, right? So you basically use this query, right, to find everything belongs to this customer, and then because you've also returned the expiry timestamp, in the code after you return the records, you can filter them out. So that would be a lot more efficient way to do it, rather than try to index the expiry timestamp column, right? So that's just something to watch out. So now come back to a little bit on the how many records actually got left. So this is something that's quite interesting. and it took me, it's actually quite a bit of effort to test this out. So now you can see there's 18 records in there, right? So now the 2 records that got expired, there is actually a way to monitor that activity. This is through the metric explorer, right? Maybe let's look at the most recent ones. So there was a activity there. It's based on, if you look at the results metric, it's called Datastore request TTL deletion count. So this is the metric. In the metric explorer, you can actually see on when the deletion activity has actually happened. So you can see this is a low priority task and start deleting things, a bit by bit behind the scenes without you need to kind of worry about it. But this is a way you can actually see the deletion has been triggered. So, but it's not like triggering everything deletion all the time, right? Because the data is distributed into many different nodes behind the scenes. So the cleanup process is basically based on, whatever that is the next kind of prioritized task to do. And this is a very low priority thing. So it might just take a very long period of time to delete all of the things you need to delete. So now let's kind of go back to a little bit. So you've seen the, how this actually works, right? So you've seen the, how you can actually set the TTL policy to make the data automatically expire. You've seen the GraphQL query I've showed to you that you can actually use this to fetch all of the associated records against the customer in this particular case. But there's many caveats actually coming with this solution. So I want to actually go through this in quite a bit detail because this may affect how effectively you can actually use this thing. First of all, it's difficult to check the TTL policy has been successfully set because there's no validation. So this is, in my opinion, is quite an important one. What I mean by this is, if you look at this thing, right? So you can actually create a policy based on whatever, right? You can literally put first name in there, right? And then you can even put in a column that doesn't even exist, and then you can just basically go ahead and create it, and this will basically create it. But it won't work because the first name is not a timestamp column, right? It just has some strings in there. It does not even a ISO standard timestamp. So this is never going to work, right? And but how do you know this is actually going to work? There's no validation in there. So this is quite a big issue for me because if you set something, even let's say when I set this expiry timestamp earlier for the transaction, right? I didn't know whether it worked or not. So I was sitting there basically for hours trying to see if it's actually, is this the right way to use it? Is it actually working? What if I have a typo in there, right? So I think this is quite a big problem for me, which I will feed back to the Google Cloud team to see what they're going to do about this going forward, because it is very important to have some sort of validation so it's actually working, right? Because this stuff is not like you can actually check it, because you kind of have to rely on this monitoring maybe for hours. But if you rely on some of these use cases such as sensitive data expiration, how do you actually trust it, right? If you don't know if it's been done or not. So it's quite a big problem without validation, in my opinion. So the second thing is it takes quite a long time after the expiration, right, for the timestamp records to be actually cleaned up. So the typical the documented hours is basically 72 hours. So Google says within 72 hours, those records would have been gradually cleaned up behind the scenes. So that's okay. But again, back to the validation issues, if I have to sit there and wait for 72 hours, I don't know how long it's going to take, right? So there has to be some way for a user to validate this stuff a little bit easier rather than just chuck something in, doesn't have validation, it may or may not work. But this 72 hours is just something you need to keep in mind, because if you actually, as I showed in the GraphQL queries, if you actually retrieve the records, you should not index the expiry date, right? Because if you do that, that's going to potentially create hotspots depending on how much data you've got and then how condensed your data is. But instead, if you actually, in the structures in the design, if you want to retrieve something based on a parent record like customer, you can find all the transactions and then filter them out in code right afterwards. Especially when it downs to the individual record, it's never really that much data. So it's better to filter out in the code instead of trying to do it on storage engine. It's not designed for that. The other thing is it kind of took me quite a long time. I still don't really understand why it's designed like this. So if you look carefully, right, so Datastore is designed based on a namespace. So if you click on any of these records, or when you're creating an entity, you can see here, it's like namespace is designed for the multi-tenancy use case, right? So, and that means you can even have the same kind across different namespaces. But when setting the TTL, whether that's through the UI or through the command line, doesn't seem to give you an option, right? So all you have is a kind, and then the name, the column, the field name. And what I found quite interesting is I was wondering whether this is just going to try to delete anything that it matches across multiple namespaces. And I think that's what it did, right? So if you look at I've basically replicated the 20 records in a different namespace in custom application 1, right? If you look at here, now I've got 19 records here. So when I had 20 initially, then I start deleting it here as well, right? But that's in a different namespace. So basically by setting it on any kind, you just need to be careful. Like if you have multiple applications that some may have a expiry timestamp, right? The other may have, but you don't really have the choice, it seems like, not to remove certain things in certain namespaces, right? But it's also like the other issue is if you actually got something is exactly the same name, such as you call it transaction in both namespaces, but actually means something else, then this is quite tricky because you can only create one TTL policy per kind, then which means you can only do TTL for one namespace, not the other. So it's something that doesn't really make a lot of sense to me. So again, this is something I'm going to feed back to the Google team to see what they're going to say about this, and I'll update you on the video. Okay, the last thing is around setting up the TTL policy. Takes quite a long time. So this is basically when I'm setting this one. You can see I've created this one earlier, right? So it takes around, I think it's about 15 minutes to do it. I'm not entirely sure why it needs to take that long. I guess depending on how you set up the backend processes, but I think you have to wait around 15-20 minutes for this to be completed. I don't think it matters too much to you, but if you because this thing also takes up to around like 72 hours for things to be cleaned up. So yeah, so these are the kind of the things I think is quite important to summarize it. So when you're using this feature, just make sure you're aware these are the caveats. It actually might cause problems to you, especially the namespace one, which can be a little bit dangerous depending on what you're doing, right, in your system. Finally, I want to quickly go through this, probably the most important page describing how you would actually manage the TTL policies. There's a few things I want to cover in here. Obviously, the 72 hours expiry date is the one that's been mentioned. So it's not like a clear answer, but it's typically within 72 hours. So this is not this is by design, right? So this is not a problem. So even you look at DynamoDB, I think they said about something like 48 hours. So it's a very similar behavior. It's just because this deletion kind of operations is usually very expensive in terms of resource hungry. If you delete it, manually, it will consume a lot of resources, and it's difficult to manage. But if you manage it as a TTL, it typically uses the kind of backend compaction process, which doesn't happen very often. It might happen every hour for the the small compactions, and then you got the major compactions, which can happen, I don't know, like every few days. So it depends on how many records gets cleaned up in which compaction and where, like which machine. So that's why it's kind of designed like this. The pricing, I wouldn't worry too much about it. This is kind of it's very cheap for the deletions either way. This is the one that with the namespace I mentioned, you can only have one property per kind, right? So, but then what if it's across different namespaces? That's kind of a quite big question mark for me. and then only 200 TTL policies allowed. So this is overall. So you just have to keep in mind, if you have so many different namespaces, so many different kinds, then just make sure you don't hit that limit. This whole section is about deletions. I recommend you just read this in full as well. And the 72 hours thing is mentioned in here again. The other things, like the things we already observed now, I described that it does not delete things in any orders. It does not delete things at the same time. It's basically a low priority cleanup process over a period of time. Then it will do that in its own time. So if you are relying on this feature, don't rely on it's guaranteed going to not return those records back to you anymore after the expiry date. That's not going to be accurate. So you have to do the filtering yourself in the code. And again, here it mentioned on the basically not following best practice is trying to index the timestamp field. It's very important that you don't index the timestamp field, because it can create hotspots, right? So yeah, and the very bottom is got the two monitoring metrics, which I've showed you already in the metrics. So it's quite useful. It's something you can use for monitoring, so you can see if this kind of activity is actually happening. But then again, these caveats, I think it's quite a new thing, but considering it's in GA, I'm kind of a bit surprised that it's got this many issues. But I'll keep you guys updated once I've got more information on how this can be managed better, especially how you can manage the namespaces, how you can actually test this a little bit better. If it doesn't even have validation, how do you know it's actually worked, right? So that's just one of these things. Okay, I think that's the end of the session. Hopefully this is useful to you. Just walk you through and run through this whole feature of the TTL for Datastore. Yeah, and I'll keep you guys updated once I've got more feedback, the answers from the Google Cloud team, to see what we can do about some of these issues and how to improve these. Okay, thanks very much, and then that's the end of the session. I'll see you next time.